As accountants, we will likely be the go-to person to retrieve data from your database. And this can be achieved through SQL, sometimes SQL, but what it stands for is Structured Query Language. And this is a computer language designed to query data in a relational database. Okay, it's based on relational algebra. It allows a user to query and update the database. And in a database, while queries allow the user to access, read, and report undesired data, the responsibility to actually making physical changes, though, would reside with our database management system. So there are specific statements as accountants that we will use to retrieve the data that we're looking for. On the slide, we can see that the select statement is used to begin a query, and it tells the query which columns or attributes that we should be including, while the from clause to the select statement indicates the name of the table from which to retrieve the data. Let's go through an example. So in our example, we have the customer table in front of us, and we can see the different attributes in that table being customer number, name, looks like accounts receivable amount, and I believe this would be our salesperson number. So given these attributes, and then we've got our records here going in our rows. How do we use a query to find the salesperson for each customer? What we can do is we could select the attributes customer number, name, and salesperson number from the table customer. And we would get the following query results. A little bit, it stripped out some information that maybe we didn't need in the big table that we would have originally gotten. The where clause states that the criteria that must be met to be shown in the query result. So in this instance, we only want to know or retrieve all the cash receipts from customer C2, and now we're looking at the cash receipt table. So we've got the cash receipt table in front of us with its attributes. We've got a remittance advice number, an amount, a bank account, date, customer number, cashier number. Now we only want to see the cash receipts where the customer number equals C2. So here we're going to select from the cash receipt table where customer number equals C2. So these are actual commands over here, the select, the from, the where. Okay, and if we do that, we will get the following query result, which is all the different attributes from before, but now we're only seeing the customer number C2 as we indicated in our where statement. In a third example, now assume that you'd like to use the query to find the salesperson for each customer, but you'd also like to show the name of each salesperson as part of the result. And the trick is that in the customer table, we don't have the salesperson name. So we're going to be using now two tables. We're going to use both the customer table and the salesperson table. So we're going to go ahead and select what we want. We want the customer number, we want the name, we want the salesperson number, and we want the salesperson's name. And we're going to get that from two different tables. Here we have the customer table and the salesperson table. Okay? And the where, or the constraint, is that we want the customer salesperson number. Okay? So this is saying this is the table here, and we want the salesperson number in the customer table to equal, here we're referencing a new table, the salesperson number in the salesperson table. Okay, this is that link between tables. We can bring in an item or an attribute such as the salesperson name if there's a common attribute, which in this case was salesperson number. If we go back we can see that salesperson number was an attribute in both tables. Okay, so that's what's allowing us to do that, and we'd be getting the following result. We'd get our customer number, name, salesperson number, and then here's that salesperson name, which we were able to pull from the salesperson table. SQL also has for us a grouped by operator, and that's used with aggregate functions on the query results based on one or more columns. So let's look at another example using the grouped by operator. So we can refer to the cash receipts table in SQL example 2, and we're going to assume that you'd like to know the total cash receipt amount from each customer. If you use the following SQL command, we can get the result. So let's take a peek and see what they did here. So we selected a customer number table. Okay. I'm sorry, we're selecting the customer number attribute. And we are doing a sum amount. And this is coming from the cash receipt table. And we're going to group by customer number. So if we do those, what it's going to do for us is group the customer number and sum for us. In SQL, we could also use the order by clause, which identifies the columns that are used to sort the resulting data. So if we wanted to, we could do a very similar as the last example by using the cash receipts table from example 2. And if we use the SQL commands on the next screen, the amount of cash receipts would be ordered in ascending amount or descending amount, depending on what we say. ASC would be for ascending, DESC would be for descending. So let's take a look and see what that looks like. So from our cash receipt table, where our customer number equals C2, we're going to order by amount, and we want ascending, so we say ASC. So that'll give us just our C2 customers, and we're going to go ahead and see that they are ordered in ascending order based on the amount. Okay? Continuing on with SQL, we have some other operators or clauses that would be of interest to you. The insert to operator actually inserts data into the SQL table. The update operator is for updating data. We got the delete from operator, which will delete data from a SQL table. Select distinct clause selects a column without showing repetitive values. That one could be very useful. And the between operator can be used to specify the endpoints of a range. We also have membership operator, parentheses of in, allows you to test whether a data value matches the specified target values. There's also some relational operators in SQL. A lot of these make sense, so an equal sign would be equal. Here we've got two different options for not equal. I've seen this one quite a bit. Less than or equal to, greater than, these are all pretty common sense. SQL also offers convenient aggregate functions, as we see here listed. We can use the average, sum, max, min, and count. Which could be very useful in certain instances. So just another thing to point out. Well, that's our overview of SQL. Thanks for joining me.